Yes, this is Professor Bennett-Bell, and we're going to look at some truth tables. Okay. So here's one right here. We have P could be true, true, false, false. Q can be true, false, true, false. This is how we typically look at truth tables. And we're going to start off with an and. So and we have to make sure we understand that both must be true to have a true truth table. So here we have P and Q are true. Okay, the next one we have P is true and Q is false. So right now we're reading from left to right. So P and Q, P is true and Q is false. Both of these are not true, therefore it results in false. Then we have P is false and Q is true. Those both are not true, therefore they're false. And the last one, Q and P, or P and Q, are false. So obviously this is false. So just to review again, for the and, for the logic table, the truth table, and both of these must be true to result in a true statement. Now let's try something a little bit more challenging, but we can do this, not a problem. So here we have or. Or can be either true for P or true for Q. So either of these can be true and can result in a true statement. Where with and, both have to be true to result in a true statement. So that's the difference here. So our end result we're looking for here this is our goal. But to get here, we have to first look at what they gave us. True, true, false, false, true, false, true, false. And then we have to conduct a not P, the negation. So P right now is right here. So let's go ahead and circle that so we know what we're focused on. So this is P right here. We want to know what's not P. What's not P? So right now it says for the first one is true. What's not true is false. For the second one, it says true. What's not true is obviously false. For the third one, it says false. What's the opposite of false? True. And for the fourth one, it says false, opposite of false, true. So negation is literally the opposite of the statement that they originally give us. So now we're looking at not P or Q. So for this statement, we are going to focus on this part. Okay, so not P is false or true. Okay, so not P is false or Q is true. You're going to look at, are either of these, this is an or statement, are either of these true? Yes, therefore the statement is true. The next one, not P is false or Q is false. Are either of these true? No, therefore it's false. The next one, we have not P is true and we have Q is true. Both of these are true, so either of these are true. And then for the last one, we have not P is true or Q is false. Are either of these true? Yes, therefore this is true. So this will be your answer for this statement.